bricks by injection molding. Each hollow brick has a wall thickness of 2 millimeter. So it's a hollow brick, and think of a brick as a five-sided shoebox without a lid. The outside dimensions are given for the brick 31 by 16, and the depth is this much. The top of the brick is this one. 10 bricks are made. Determine the screw RPM to make a shot in 3 seconds. So Q, we have to find out what is the VZ for the screw. So Q screw is the volume divided by time. And the height, let's plug it in. Height is 6. Okay. And the width is 25. This is 25. The viscosity, the eta is 200. And the back pressure is given 375. 375. This is 370. Okay. This is 375. Kilopascals. So I'm going to convert it in 10 to the power 3. And dz is nothing but the axial length. Suppose these are the helix. So this is the angle of the helix. This is the axial length. This is my dz. So L over dz equals to sine theta. The helix angle is 18 degrees. And the length of the screw is 1.1. So you can find out dz from here. dz equals to L over sine theta. So let's find it out. And VZ, you can find VZ. This is my, suppose this is my screw. This is the barrel and this is the screw. And the tangential velocity of the barrel or the screw, they are the same. Okay, barrel of the screw, they are the same. But this velocity has two components. VZ along the helix, perpendicular to VZ, which is stirring velocity, which we don't use usually in the problem. We use just the uh, along we also call it the pumping velocity. We keep on pumping the plastic towards the mold or the die, and VZ equals to VB cosine theta. VB or VS. I would say in this case, this is not the barrel which we are interested. We are interested in screw. And V screw, you can find out using this pi dn over 60. What is the diameter of the screw? You will subtract the height. If the diameter of the barrel is given, the barrel diameter is 28. Can you find out the screw diameter? You just subtract h 2 times. So let me write down the screw. So the screw diameter is equal to the barrel diameter minus 2 times the height of the flight, which is 6 millimeter. Okay, so I can write down 28 which is 16 millimeter. This is the diameter of the screw. So let's find out Q, and for that we need to find out the volume. So I would like to see how did you calculate the volume. I will say this is the Lego bricks. So I'm just pretending it looks like a shoe box without the lid. That's what it is. Think of a brick as a five-sided shoe box without a lid. So this is a hollow inside. So if it is 31 by 16 and by 16, or if I do this like this, so 31 minus 2 inch, if you say 2 millimeter, you subtract 4 from each side. This you have to subtract that. So let me write down the volume. Volume of one brick, it is equal to 31 times 16 times 16, and subtract the diameter. Subtract that value. How much is this? This length is how much? Like 27. And you have to subtract this. How much is this? 16 minus 4. 2 here, 2 here is 12. 27 times 12 without the lid. So I will assume this is the bottom has the thickness of 2 millimeters. You have to subtract uh 16 minus 2, so 14. And this is the volume of one brick. Now in one shot you are manufacturing 10 bricks. It is said over here, in one shot 10 bricks are made. So you have to multiply the total volume by 10. And then you will divide by the time. The shot is prepared in 3 seconds. The time is 3 seconds. So Q equals to that. Q is equals to the Q screw, which is volume divided by time. So if you do the math here, so volume is equal to 34,000 millimeter cubed, and divide by the time, which is 3 seconds. So the discharge or the flow of the plastic from the screw into the mold cavity, it is 11,333 millimeter cubed per second. So once you get this flow, you will plug it in this formula, and then everything is given. You see my point? Except Vz. So you have to follow these steps in order to complete this formula. Make sure you understand this formula. So let's plug it in over here. I'm going to use this formula here and show you how the variables are plugged in. Q screw is 11,333. The width of the channel is 25. The normal width is 25. And then parenthesis starts. VZ, you have to find out. The height, flight height is 6. Divide by 2 minus 6 cubed in millimeter. Divide by 12 into 200, which is the viscosity, 200 plus Pascal seconds times 375 to the power 3 divided by dz 1100 divided by sine 18. So you might be confused about the units, but the units are correct. You have to go home and practice this. So Vz can be found from here. Vz equals to pi dn over 60. Let me write down this formula. V equals to linear speed is pi d, which is the circumference times number of revolutions in 1 second. Pi d, and d already is the screw diameter, which you already calculated, which is 16. Okay, that is 16. You will plug it in over here. Pi times 16 times n divided by 60, and if you do the math here, the n comes 194 revolutions per minute. After you find the revolutions per minute, the next question is asked, what is the clamp force and when the injection pressure is given. So you have to clamp the die if the injection pressure is given, which is 68 megapascals. Injection 68 megapascal, and P equals to force divided by area. So area for the bricks, this is area like 31 times 16, and you have to multiply 10. These are the 10 bricks. So I can write down the area 31 times 16 times 10, which is equal to 4,960 millimeters square. You can this is the clamp force when you are injecting the plastic into the die, which is like this is the die, and the gate and the runner, and this the screw portion, okay, and the barrel portion. I'm just showing you the rough sketch. And now force injection, a clamp force equals to injection pressure times area, and that gives you the answer 337,280 newtons. And the last question, last part of this question, determine the cooling time. And for the cooling time, you need to use this formula. We already understood similar problem earlier. So let's use this formula to find out the cooling time for the Lego bricks, 10 Lego bricks. So what is my alpha? Alpha equals to K over rho times C. K is given, thermal conductivity is 0.123, and density of the plastic is 1040, and specific heat is 2100. I can write down here 0.123, 1040 is the density. -5.63 in 10 to the power -8 meters per second. Thermal diffusivity is this value. So the question states the thickness is 2 millimeter. You know, if this thickness is 2 millimeter, which is 2L, 2L equals to 2 millimeter. L equals to 1 millimeter. Agreed? So I can write down here cooling time 4 times L. I want to convert it into meters. 5.63 in 10 to the power -8 ln natural log 4/5 times the the injection temperature, which is 215. Here is written Tm, which is the injection temperature. Here in this case this is 215 Celsius, and the internal wall of the mold temperature of the internal walls is ejection temperature is 100 and the wall temperature is 50 Celsius. So I can write down 215 minus 50 minus 50 and 100. Ejection temperature is 100 Celsius. That's good. So everything is known except TC. So if you do the math, you should get the cooling time of 10.3 seconds. This is your answer.